Hello students, in the previous lectures we have studied law of parallelogram of forces. But what is the limitation of law of parallelogram of forces? It is that parallelogram can find a resultant of only two forces. But what if more than two forces are acting at the same point? Then we have to find resultant by applying some another method. Okay, so let us start another method, resolution of more than two forces. Okay, so let us start now the next method number 2, or say topic number 2, resolution of more than two concurrent forces. So what is the resolution of more than two concurrent forces? In the law of parallelogram, we have studied that at a point only and only two forces are acting there. But now at the same point more than two forces are also acting. See the figure. In this figure, at the origin there are number of forces acting. Force P1, force P2, force P3, force P4. Also, the angles with respect to x-axis of these forces is given to you like this. P1 at an angle theta 1 from positive x-axis, P2 at an angle theta 2 from negative x-axis, P3 at an angle theta 3 from negative x-axis, P4 at an angle theta 4 from positive x-axis. You just notify all the things. Must remember, all the angles are with respect to x-axis only. There is no angle which is with respect to y-axis. Okay, each and every angle must be with respect to x-axis. Let us see what happens. Consider these four forces and you have to find two values. First one is sigma h, means algebraic sum of horizontal forces. Okay, means addition of horizontal components of the forces. You may understand horizontal components. Suppose this is the axis. A force is acting like this F, and angle is theta with respect to x-axis. Then there are two components, horizontal component and vertical component. Horizontal component is F cos theta, while vertical component is F sin theta. Okay, all of you are aware about this. So what we conclude, sigma h means all cos components and sigma v means all sine components. So algebraic sum of horizontal forces means addition of all the cos components, and algebraic sum of vertical forces means addition of all the sine components. Now what we have to find? We have to find resultant again, R, same way like in the parallelogram law of forces. So what is the formula over here? The formula is changing. R is equal to under root of sigma h square plus sigma v square. Where is sigma h? Here it is. Where is sigma v? Here it is. So replace the value and you will find R equal to under root of sigma h square plus sigma v square. Also you have to find theta, means angle of resultant with horizontal. The formula for that is tan theta is equal to mode of sigma v upon sigma h. So you have to calculate two main things. First one is resultant and second one is theta. Okay, so this is the very simple method. Now there are four cases. If sigma h, if answer of sigma h is positive and sigma v is also positive, then the resultant will be in the first quadrant. You can understand, horizontal plus vertical plus means first quadrant. Similarly, four cases. You all are aware about the quadrant system 1, 2, 3, 4. If sigma h is negative but vertical is positive, then resultant will be in the second quadrant. If sigma h is negative, sigma v also negative, then resultant is in the third quadrant. Likewise, sigma h equal to positive, sigma v equal to negative, then the resultant will be in the fourth quadrant. So these are the 4 different positions of the resultant according to the quadrants. So basically this is the system in which we are finding the resultant and its angle with respect to x-axis for more than 2 forces, 3 forces, 4 forces or many forces. Okay, so this method is used for solution of more than 2 forces. Now let us check another topic. See this is the most important question and very short question. Condition of equilibrium of coplanar concurrent forces. What is equilibrium? If at a point 1, 2, 3 or many number of forces are acting, but this point is not moving anywhere, means the resultant effect on the point is 0, then this is known as condition of equilibrium. Okay, so what is the condition of equilibrium? First one is sigma h should be 0, means algebraic sum of horizontal forces must be 0. Okay, horizontal forces, horizontal components, cosine components must be 0. Addition of vertical forces is also 0, means algebraic sum of all the vertical forces must be 0, means addition of all sine components must be 0. Now since sigma h and sigma v both are 0, resultant is also 0 according to the formula of under root of sigma h square plus sigma v square. But sigma h, sigma v both are 0, so resultant must be 0. So this is the condition of equilibrium. So if it is given in the example that resultant force is 0, then condition is in equilibrium. Reverse, if the force or if the force system is in equilibrium, then we can say that sigma h must be 0, sigma v must be 0 and resultant is also equal to 0. Okay, now let us start some examples. I will show you 1 or 2 examples of this method. Check this. Example number 1. You can study the figure carefully, read the data, determine the magnitude and direction of the resultant force of the force system shown in figure. What we have to find? We have to find 2 things. First one is magnitude and second one is direction. All of you know about this. Magnitude means r, direction means alpha, or now we can say direction is equal to theta. So we have to find 2 things, r and theta, for this example. You can see in the numerical figure is given. Check this first figure. There are 4 forces. First one is 100 Newton, second one is 120 Newton, third one is 130 Newton and fourth one is 100 Newton. Okay, now check out angles. 100 Newton is at an angle 60 degree with x-axis. Second force 120 Newton is along the y-axis, along the positive y-axis. Third force is 130 Newton, but its angle is not given. See carefully, its angle is not given. Check this, its angle is not given. Okay, but slope is given like this, 12 by 5. So how we can find angle with respect to x-axis? So you can apply this formula, tan theta. What is tan theta? Actually tan theta is equal to opposite side upon adjacent side. So opposite side is 12 and adjacent side is 5 for this small triangle, slope of the triangle. Okay, so tan theta is equal to 12 by 5, 2.4. By doing tan inverse, you can get theta equal to 67.38. It means what? This force is making 67.38 degree with x-axis. So you can find theta over here. So this is the equivalent figure converted. Okay. So now theta is available. The fourth one is 100 Newton force. 100 Newton force, it is making 60 degree with positive x-axis. So in the case 2, this is the simplified figure. First force, second force, third force, fourth force and respective angles. Sorry, one more force is there. You can see over here, fifth force, 50 Newton. But this 50 Newton is going in right side x direction, compressive force. So this is the most important topic. When at origin 4 forces, 1, 2, 3, 4, all are tensile. But only this force is compressive, 50 Newton. So first make it tensile. So 50 Newton force is now going towards right side. So make it tensile like this. Okay. So remember two steps. First step, angle of all the forces. Remember again, angle of all the forces must be available to you, but with respect to x-axis only. You have to find all the angles with respect to x-axis only for all the given forces. Second step you have to remember is all the forces in the system must be tensile. No force should be compressive. You have to convert it into direction of tensile force. Okay, so these two steps are most important for this example. First one is angles of all the forces available to you. Second one is all the forces are tensile forces. Okay, we have already find that theta is equal to 67.38 for this force. This theta is 67.38. Okay, let us start now. Clearly concentrate over here. We are finding sigma h now. Sigma h means all horizontal components, cosine components. So starting from the positive x-axis always. Okay, must remember the method. Start from the positive x-axis always. What is first force? First force is 50. Now angle you have to measure with positive x-axis only for all the forces. Remember this thing, angle you have to measure with x-axis, positive x-axis only for all the forces. So what is the angle for this force? The angle of this force 50 is equal to 0 because itself it is on the x-axis. So first component is 50 cos 0. You can see 50 cos 0. Next force 100 Newton. Angle is 60 degree with x-axis. So second one is 100 cos 60. Next force 120 Newton. But angle is 90 from x-axis. So 120 cos 90. Okay, you are getting the method right now. Now the next force is 130. Now important. This 130 force is in second quadrant. But you have to measure angle with positive x-axis only. So what is this angle? We have studied in the introduction. This angle, let us show you by different color. See this. This theta is 67.38 degree. Now this total angle is 180. So what is the angle of red color? What is the angle of this color? Tell me. So it is equal to 180 minus 67.38. Okay, so answer will be 112.62. So this is the angle of 130 Newton force. Next force is 100 Newton. Again you have to find angle with respect to positive x-axis only. So it will be 360 minus 60. Okay, this total circle is of 360, but you have to minus out this 60 degree angle. So 360 minus 60 is equal to 300 degree. So these are the horizontal components. Remember and listen me carefully. First force is 50, angle is 0, so it will be 50 cos 0. Second one is 100, angle is 60, so 100 cos 60. Third force is 120, so 120 cos 90, angle is 90 degree. Fourth force is 130, angle is from x-axis 180 minus 67.38, so it will be 112.62. Fourth force is 100, angle will be 300. In the calculator you can find these values and do the sum of these values, then answer will be 100 Newton. It will be positive 100 Newton. So arrow towards right side means in positive x-axis. Okay, so this is the answer of sigma h, 100 Newton. Now let us check sigma v. So very shortcut method. Now you don't have to follow the figure. Okay, shortcut method. In the sigma h values, all the sigma h values, just copy all the values over here in sigma v, but replace cos by sine. See, angle is also not changing now, just replace sine in place of cos. So it will be 50 sine 0, 100 sine 60, 120 sine 90, etc, etc. So by calculating these values in your calci, sigma v is equal to 240 Newton, positive 240 Newton. Positive 240 Newton means it is along positive y-axis. So arrow will be upwards, direction will be upwards. So this is very simple method. Sigma h available to you, sigma v available to you. So what is the formula of R? Under root of sigma h square plus sigma v square. Calculate this. So answer will be 260 Newton. So R is equal to 260 Newton. Where is the position of R? Sigma h is positive, sigma v is positive. So resultant R will be in the first quadrant only, as we have discussed. Okay, there is an alternatively second method also there, but this alternate method we will see in the next lecture, in the next examples. Okay, so I am not confusing you right now. So just remember this method right now: sigma h, sigma v, and resultant. Now what we have to find? Check out this. We have to find the location of the resultant. As I told you, sigma h positive, sigma v positive, so resultant is in the first quadrant. But we have to find x, we have to find theta with respect to x-axis, means position of this resultant. So for that, tan theta is equal to sigma v by sigma h. Sigma v by sigma h means 240 by 100, 2.4. Doing tan inverse, theta is equal to 67.38 degree. So sigma h positive, sigma v positive, R will be in the first quadrant, and it is at an angle 67.38 degree with respect to x-axis. So this is basically the numerical. Very easy. First step is find sigma h, all cos components. Second step is find sigma v, all sine components. Then after formula of R and formula of this tan theta. So you can calculate R and theta and its location. See, to draw the location in the exam is very compulsory. Let us see another example. In the example 2, you can check the figure. How many forces? First one is P, second one is 100 Newton. See, first force P is unknown now. Second one is 100 Newton, third one is 200 Newton. And fourth one is 150 Newton over here. So total 4 forces are there. Okay. But now in this sum, resultant is given to you. Most important, in the first example, resultant is not given to you. But in this example, resultant is given to you. And direction is along positive x-axis. Okay, now angles. Angle of P is not given, it is theta. Now, angle of 100 Newton is given with respect to y-axis, that is 30 degree. And angle of 200 Newton force is 60 degree with respect to x-axis. What is the data? A system of 4 forces shown in figure has resultant 50 Newton along positive x-axis. What we have to determine? Determine the magnitude, means value, and inclination, means angle of unknown force P. So you have to find P and you have to find theta. Okay. So very important turning point. A resultant is given and it is along positive x-axis. So you have to take R equal to sigma h is equal to 50 Newton. Okay, R is equal to 50 Newton. So it will become sigma h now. You are wondering that why R equal to sigma h? Because resultant is totally in h direction, horizontal direction. So there is no effect of this resultant in vertical direction. So resultant will be is equal to horizontal components. Resultant is not doing any effect in vertical direction. Okay. So such type of cases, in such type of cases, you have to take R equal to sigma h and sigma v equal to 0. Okay, are you getting? Sigma h is equal to 50 Newton and sigma v equal to 0 because resultant is in x-axis, is in along the x-axis. If resultant will be in the y-axis, along the y-axis, then what happens? Then R is equal to sigma v and sigma h will be equal to 0. Okay. Check out next sigma h. Find sigma h with the help of same method. What is first force? 150. Angle is 0. So 150 cos 0. What is next force? P. Angle is theta. So next component is P cos theta. What is next force? 100 Newton. So angle now 100 Newton from positive x-axis. So it will be 90 plus 30, 120. So 100 cos 120. 200. But angle from x-axis 180 plus 60, 240 degree. Okay. So 200 cos 240. Addition in the calculator. But resultant is given to you 50 Newton. So is equal to 50. Now by doing calculator, this term will become unknown, P cos theta. Calculate remaining terms in the calculator. You will get this equation 150 plus P cos theta minus 50 minus 100 etc. The values you are getting in the calc. So what is the final equation? P cos theta equal to 50. P cos theta equal to 50. You can do the rough work in your notebook. You will get this equation P cos theta equal to 50, equation number 1. Now what happens? Same way find sigma v. All the values are repeated. Don't show the figure. All the values are repeated sigma h. Okay, just copy it in sigma v but replace cos by sine. So P sin theta 100 sin 120 like that. So you will get another equation P sin theta equal to 86.6. What is first equation? P cos theta equal to 50. What is second equation? P sin theta is equal to 86.6. Now what you have to do? You have to do division of this two equations. Divide equation 1 by equation 2. So you will get P sin theta upon P cos theta equal to 86.6 upon 50. So what happens? P are getting cancelled. Sin upon cos will be tan theta. So tan theta is equal to, in the calculator, 1.732. By doing tan inverse, theta is equal to 60 degree. So this angle is now available to you. First answer is complete. Theta is equal to 60 degree. Now replace this theta in any of the equation. Equation 1 or you can say equation 2. So you will get P sin theta equal to 86.6. But sin theta is equal to something by this sin 60. Sin 60 you can find in the calc. So finally you will getting P is equal to 100 Newton. So what is the target? We have to find P and we have to find theta. So here it is theta and here it is force P. So these are the two varieties of the numericals. In first numericals, that is basic numerical, all the forces are given. We have find sigma h, sigma v and resultant. In the next force, it is given that resultant is available to you but along positive x-axis. So R equal to sigma h and sigma v equal to 0. And we have to find unknown force P and its inclination theta with respect to x-axis. So here is the calculation. Okay. So these are basically the method in which we are finding forces or resolution or resultant of forces more than 2. It is the limitation of law of parallelogram that we can find resultant of only 2 forces. But by this method, by using this method, we can find resultant of more than 2 forces also. Okay. So these are the examples, 1 or 2 examples by this method. So just recall this, practice this today. We will see some tough numericals based on this method in the next lecture. So thank you students for the support. Now we are starting next lecture with some more examples. Thank you.